Hello students, welcome to Sort of Sus classes. So we have a function f from r to r differentiable and given that f of 0 is equal to 1. Assume that f prime of x is greater than equal to 1 for all x. Now what is the smallest possible value of f5? Let us solve this problem by drawing a graph. Now we have f of 0 is equal to 1. 0. Now the line fx is equal to x plus 1. I call this function g. Then g of 0 is equal to 1 and g prime of x is equal to 1 for all x. The graph of g is precisely this, crossing minus 1 at the y-axis and crossing plus 1 at the y-axis and minus 1 at the x-axis. Now since f of 0 is equal to 1 and f prime of x is always greater than equal to 1, f lies in this region. So the minimum value of f5 is exactly equal to g5, which is equal to 6. Therefore D is the correct answer. Now let us move on to the next problem. The next problem says a math contest is made up of 64 multiple choice questions, each worth either 0 if there's wrong or no answer or 1. So it's a binary question. Then the number of students who must write the test to be sure that at least 32 have the same final score is. So what is the set of scores S? The set of scores S is 0, 1, 2, 3 up to 64. If a person does everything wrong, he gets a 0. If a person does everything right, he gets a 64. And all the middle numbers between 0 and 64 are possible. So now what we need to find is number of students who must write the test. Students, the minimum number of students who must write such that 32 at least have same final score. So suppose we have B1, B2 up to B31. Suppose we have 31 boxes, each box with 1, 2, 3, 65. Sorry, 0, 1, 2, 3 up to 64, 0, 1, 2 up to 64. Suppose each box has 65 students getting 0, 1, 2, 3 up to 64 one by one. Now there are 31 boxes in total, so there are 31 students getting 0, 31 students getting 1, 31 students getting 2. Each of the marks in the set S is attained by exactly 31 students. Now if we add one more student, he has to fit in one box, and hence there are 32 different students who have the same final score. This is an application of pigeonhole principle. The strong form of pigeonhole principle. Since we have exactly 31 students with equal scores, adding one more student, whatever his score is, will create a batch of 32 students who will have the same final score. So the minimum number of students is 31 into 65 plus 1, which is equal to 2016. So A is the correct answer. Thank you.